Hello class, welcome to this lab on determining normality. So in this lab we're going to be looking at a set of data and we're going to determine if the data comes from a normal distribution. So we want to see, like, based off of the data that we collect, does it follow a normal distribution or is it approximately normal? So we're going to be doing a couple of tests for that. So let's get started. We're going to actually look at the histogram first for this set of data. So now this set of data right here was taken from a database that includes global data. So it's internet, has all the different countries throughout the world for different time periods from 1810 all the way to I think late 1900s. And it includes heights of males. So these are male heights taken randomly from countries. So what we're going to do is this is roughly 1,000 something data points. So about 1,251 data points. So what we're going to do is we have such a large data set, I want to reduce it to about 30 data points. So what I'm going to do, just to kind of simplify things and simplify the calculations for you, since you are going to need at least 30 data points, what we're going to do is we're going to select 30 data points randomly from this data set. So how do I select data randomly from this? Well, first, you want to make sure that the data set is ordered in some way. So for example, I went ahead and ordered this by the year. So I went ahead and did a sort. You can highlight all of the data and sort it. Maybe you want to sort it alphabetically by country, whatever you want to do, but make sure that it's, semi-sorted in some way. And then what you want to do is you want to randomly pick from those numbers. So in order to do this, to facilitate this, we're going to use an Excel function. And the Excel function that we're going to be using is rand. And that gives you a number that's greater than, between 0 and 1. However, we wanted to use rand array. Now what that does, it returns an array of random numbers for you. So we're going to do rand array parentheses. Now we want to figure out the number of rows. So we're going to say, okay, so I just want to generate 30 numbers. So I'm going to do 30 for the number of rows. I'm going to do one column of numbers, comma, and then I'm going to type in the minimum number that I want to use. In this case, I'm going to use the number 2 because Angola is number 2, is row number 2. And then Argentina is row number 3. And then I want to end this all the way so that I cover all of my data. Zimbabwe right now is at 1251. So I'm going to go type in 1251 for my maximum, comma, and then I'm going to say true for integer because I want it to be an integer. I don't want it to just be a random decimal. Okay, so I'm going to go ahead and enter that now, and it's going to give me 30 numbers randomly from that list. Okay, so it's going to give me 30 of those rows. Okay, so here this is saying, okay, well, you're going to look at row 762, and that's the data point that you're going to choose. So I'm going to go to row 762. All right, so I'm going to go to my data. 762 happens to be Guinea, so Guinea-Bissau, I don't know how to pronounce that. And then I'm going to use 169.4 as my data point. So 169.4, and so on. So now when you do this, what I would do is, since these numbers tend to change so often, like if I click outside of it or if I type something, it's going to mess with the numbers in the array because the array is generating another set of 30 numbers. So what I would do is I would actually type in the numbers because for some reason it doesn't let you manipulate the array. So as soon as you get the 30 numbers, I would just type those numbers up. Actually, what I would do here, since see the numbers change so often, so I would suggest either like taking a picture and then typing in the numbers, or or you could just randomly generate 30 numbers on your own. So if you want to do that, you can use the random, just a rand between function. So let's see, a random number between 2 and, I forgot what the number was, 2,125, something like that. Let's see, 1,251. Okay. So 1,251. Okay, so that'll generate a number between that. I believe, yeah. So it generates a random number between those. And then what you could do is you could probably copy and paste this multiple times and get different numbers. So let me get rid of this set of numbers here. Okay, let me see if I type in a random number. Okay, so it does tend to change. I have no idea why it would change. However, you could just at that point copy and paste the numbers, but paste it without the formula. So just kind of paste the values themselves. Okay, and hopefully, now if I type in a number, there you go. It's not going to mess with these numbers, okay? So these numbers will stay fixed. That way they're not changing every single time you're trying to do something, okay? So that's what I would suggest. So again, to kind of review that, I would suggest either using the array or using the rand. So either rand array or rand between. This one's probably easier to use. From 2 to whatever number you have for your data points. Do that, you know, X amount of times. If you need to do it 30 times, so you just do it until you get 30 numbers. Then I would copy and paste those numbers, but paste only the values. Okay, that way the values stay fixed, and then the numbers, they won't change. Okay, so in any case, now that we went over through how to determine the random numbers, you're gonna take those numbers and you're gonna type them into the table. All right, so what I went ahead and did now, I went ahead and actually typed in the data numbers. So I used my random numbers in order to type in the heights for that. So for example, if it gave me a number of 5, I use 164.9 for Benin. So that's just an example. So I used all the 30 numbers that I randomly generated, and so now this is my 30 set of observations. Okay, so now I got my data, my 30 numbers. Now I'm going to generate a frequency, a histogram. I'm going to generate a frequency table from this. So what I want to do is I want to sort this data first. So I'm going to go ahead and sort the data. So I'll do that over here. Okay, so I'm gonna highlight all of the numbers. Then I'm going to hit data, then hit sort. Actually, so we don't need another column after all, but that's fine. Okay, so we got our data, we got it sorted. So now that we have the data sorted, what we're going to do, so now this is my heights in centimeters. So now what I'm going to do is I'm going to actually calculate, well, I'm going to determine the interval and I'm going to determine the frequency. Remember, for a frequency table, you need those two things. So what we're going to do is determine our class width. So remember, to determine the class width, you take the range and you divide it by the number of classes that you desire. So what I would suggest is for 30 observations, maybe do about 10 classes, something like that. Enough classes where you feel like it would be spread out nice and even. So let's say we're going to do the range. So we got to take the maximum. We're going to put this in parentheses. Take the maximum of our numbers, parentheses, minus the minimum, same set of numbers. I'm just going to go ahead and type them in here. And then close parentheses, then divide that by the number of classes that you want. So I'm going to choose 10 classes. okay? So I got my class width of 2.13, and then we're gonna round the class width. So rounded CW. So we're gonna round that to 2.2, okay? Remember that our data is in the tens place, right? 0 0.6, 0 0.1. So I need my class widths to be in the tens place as well. So what I'm going to do is I'm going to round the zero point 0.1 here into 0.2. So now it's, instead of it being 2.1, I'm going to make it 2.2. So this is going to be our new class width. So what we're going to do is we're going to take our minimum, which is 155.6, and then we're going to go all the way to, and then we're going to add the class width to that. So if I add the class width to that, I get 155.6 plus 2.2, that's 157.8. Okay, now if you need help adding those numbers together, you can also do this on Excel. So I'll show you how to do that. So on this column, I'm going to go ahead and type in equals. I'm going to click this number. I'm going to add my 2.2 to that number, whatever your class width is. Okay, and that's how I got 157.8. Then I'm going to go below that. I'm going to hit equals. I'm going to click the 157.8, and I'm going to add 2.2 to that number. And I'm going to rinse and repeat that process multiple times. So I'm going to now hit the 160. I'm going to scroll to the bottom right-hand corner, drag that, and just do that until you feel like you got enough numbers where you don't have to add them all by yourself on your head, okay? Just do that until you get a bunch of numbers. Remember that we did choose 10 classes, so we're going to need a total of 10 classes here, okay? All right, so the next column, or the next cell, is going to be 157.8 to less than 160, again using the 160 number here. Now we're going from 160 to less than 162.2. Now it looks like Excel actually wants to autofill some of these numbers here, right? I'm going to let it and see what happens. Okay, so I went ahead and actually filled that in for me using the numbers. However, it did not do it correctly. So I would not suggest doing this just to be on the safe side. But it was just a little experiment there. All right, so we're going to go 164.4 to less than 166.6 and so on. I got 9 classes. I need one more class. All right, and I can go ahead and get rid of these numbers now because I no longer need those numbers. Okay. All right, so now I got my 10 classes here. Now I'm going to do my frequency, so all I got to do is tally these numbers. All right, so for my frequency, I want the numbers between 155.6 and 157.8. Okay, so that means I'm going to tally these. So I'm going to include that. I'm not going to include that number. All right, so that's 1. I'm going to include this number, oh no, not that number. So that's it. So 1. Keep going. 1, 2, 3. No, just 2. Now this I messed up here, so I got to change this number. This is 162.2. All right, so 162.2 to 164.4. So I'm going to include that. That's 1, 2, 3, 4, 5, 6, 7. So it looks like about 7 observations. All right, guys, so I went ahead and fill in the frequencies by tallying up all the numbers. All right, so now that I went ahead and did that, notice I got 10 in the middle and it kind of tapers off to the sides. This is probably a good indicator that I may have a normal distribution or something that is close to it. because in the middle I have, you know, about 10, and then it kind of goes off to the sides like that. So probably a good thing that I'm having something that looks like this. All right, so now we're going to actually do the histogram. So for the histogram, we're going to draw, or we're going to insert, I'm sorry. We're going to go ahead and insert the 2D column, first option here. All right, so now what we want to do is we want to select our data. So we're going to hit chart design, select data. You're going to select your frequencies here. Then for the x-axis, we're going to hit edit here. We're going to select our x-axis values. So what we want to do is where it says series values. Let me get rid of that and choose these as my series values for my x-axis. Oops, let me double check that real quick. Oh, let's hit edit for the horizontal axis. So let me go back. So you want to go hit edit here. I believe I hit edit here. You want to hit edit on the horizontal, and we want to use these for the horizontal. There you go. So that is correct. So now we got our horizontal axis labels, and we got our frequencies, and we kind of see it's, you know, it's trying to resemble a normal distribution, right? So we can say it's approximately normally distributed. It's not perfect because again we collected the data ourselves, but you know, there's going to be a random chance that it's not going to be perfect. And the more data you collect, so here we only did it for 30 observations. If you did it for 100 observations and so on, this is going to approximate more of that shape. Okay, so, and that's of course if you're doing it randomly. All right, so now we got our histogram, but remember we need the bars to actually touch here, right? So we're going to double click the bars. Actually, let's, yeah, make sure you click on, you know, make sure that all the bars are selected when you do this. Then you can hit chart design. Let's see here. Actually, let's go ahead and right click the rectangle, the bar, and we're gonna hit format data series right here. Okay, so now what we're gonna do is we want these rectangles to touch. So we're gonna do the gap width, set that to 0. And then while I'm at it, I'm going to add some lines to the rectangles so that when they touch, you can actually tell that they're touching and where they're at. So I'm going to go hit fill in line. I'm going to put a border, and I'm going to put a solid border, a black border. All right, so now we have it. So now they touch, and you can actually tell they're not blended together because you see a solid black border. All right, this is my normal, or this is my histogram, which looks to be approximately normally distributed. So, and then we're going to go ahead and label this. This is my global heights of US males, where the n is equal to 30. So I took 30 observations. And then we're going to label this, the height. Remember to label this. You can click on your chart, and there should be a plus icon right here. You can hit axes titles, and then you can go ahead and modify them. So this is my frequency, and this is the height in centimeters. All right, of course you can make this a little bit bigger, so you can kind of extend it if you need to give you more room for the x-axis, but other than that, it's fine. Copy paste that into your report if you need it. All right, so now this is how you determine normality using the histogram. Now, if it doesn't look normal, I would suggest actually increasing the number of classes or just kind of modifying it, maybe decreasing it a little bit, increasing the number of classes, and see like which one gives you a good shape for the the histograms. Because sometimes it's just a matter of design as far as the class width and the number of classes. All right, so the next thing that we're going to show you is we're going to show you how to determine normality using a normal quantile plot. Okay, so what we're going to show you now is how to make a table for that and how to graph it. So let's get started. So we have the heights here. What we're going to do is we're going to include a counter. I'm going to call this counter, and I'm going to call this z-score or quantile. So what we're going to do is we're going to find some z-scores here. We're going to convert each of these to a corresponding z-score, and I'll show you how to do that so that we can graph that and then get the plot. So the counter, what is the counter? Well, the counter is this is what I call it, and it's just a number that helps you calculate the quantiles or the z-scores here. Okay, so we're going to start with 1, then 3, then 5. So the counter is just an odd number that we use in the formula for the z-score that I'm going to show you, okay? So we got 1, 3, and 5 for my counter. Now I'm going to continue that pattern for the rest of my numbers. All right, so I got all of the odd numbers from 1 to 59 for all of my numbers, okay? Now this counter is going to be used in the formula in this column. So what is the formula? The formula is, so we're going to type in equals norm dot s dot inverse, so norm dot s dot inv. And what this does is it gives you a z-score based off of the value that you input into the function, okay? So it retrieves a z-score from you from the z table, from the, remember the z table that we use to look up calculations for normal distribution? That's what this is going to do. It's going to look up a z-score from that table based off of the probability that we give it. So the probability, the inside, what we use is we use the counter. So we click on the counter and you divide it by, and then in parentheses, we're going to do 2 times the amount of numbers that we have, okay? So the amount of numbers that we have. So here we have 30 numbers, so I'm going to type in 30 there. And I'm going to type in one more parentheses. All right, so that is our formula. We can go ahead and hit enter, and we get a z-score. So what this basically does is it basically, and I'll kind of show you briefly what it does. So what it does is you have a normal distribution, right? And what it's doing is that we're trying to say, well, the probability, we're feeding it probabilities and getting z-scores from it. So for example, based off of our data, we're splitting our 30 numbers into, we're splitting our normal distribution into 30 pieces for 30 numbers, right? So we got like 30 numbers, and each data point represents a z-score on this table. Now, it's technically not, it's technically every halfway point. So we're taking our data of 30 and we're splitting it into 60. So if you have 30 rectangles here, then you're really doing it, cutting those rectangles in half. But what we're doing is essentially we're cutting it into 60 pieces because 30 times 2 is 60. And then we're assigning a z-score to each of those based off of the normal distribution. So that's essentially what we're doing in that formula. So this is why that formula we have 2 times 30, because we're dividing this into 60 pieces. 30 rectangles and then cutting those rectangles in half. So that's a total of 60. But you don't have to worry too much about that. This is how you actually calculate that. All right, so now we got the z-score, and we're going to we're going to copy and paste this like this so that we get the rest of the z-scores. All right, so notice that you should get some negative z-scores and you should get 0 and some positive z-scores. All right, so now we're going to graph this. So we're going to hit insert. We're going to graph a scatter plot. So you want to hit the first option for scatter. Next, you want to hit select data. Select your z-scores. All right, next you want to hit, you can hit edit here, or since this is not showing up as an option, we're going to hit edit here. And then we're going to hit the X values. So we're going to click that box. We're going to select our X values. Our X values are our data. So we're going to use the data for the X values. And then the Y value is the Z-score. Okay, so we got the heights here. We're going to go ahead and hit OK. And now we have our normal quantile plot. Okay, so this is our normal quantile plot for our heights. Let's see. Okay, and then so for our axes titles, we have our z-score in the y-axis, and our heights on the x-axis. All right, so now what are we looking for in this quantile plot? Well, what we're looking for is a linear trend. So we're looking for the data to follow a approximately linear trend. So we want to see, okay, does it, when we graph this, does it look like a line? If it does, then it's approximately a normal distribution. So this right now looks like it's following a line, which is pretty good. So what we want to do is we want to do the equation, find the equation and the r squared for this line. So we're going to hit this. We're going to hit the arrow next to trend line, more options. Then we're going to hit linear because we want a linear trend. That looks pretty good. And then we want to hit display r squared value on chart. All right. So now we got our r squared value. Remember that the r squared value being of 1 is pretty good. So if this is close to 1, that's a good thing. So now we know our r squared. Now to find our r, our little r, to find our little r, what we're going to do is we're going to take the square root, so SQRT. We're going to take the square root of that number, and that will give me my r. So that's saying my correlation coefficient, which measures how strong this fits to the line, is 0.98, which is pretty good. So we can confidently say that this this data seems to come from a normal distribution, or at least it seems to be normally distributed the way we have it here. All right, so 2 different ways to determining normality of the data that you collect. All right, so we determined 2 different ways of doing this. Now what we're going to do is we're going to do a couple of exercises based off of this. So now we know that it's approximately normally distributed. So we're going to go ahead and calculate the average and the standard deviation. Okay, so we're going to do x bar, which is my average. So we're going to do average, and we're going to select all of our numbers. This is for our data, okay? So our data is height. Okay, so we got an average height of 165.91. Now we're going to find the standard deviation, or S. So we're going to do stdev.s. We're going to do S because we're taking a sample, okay? Since we took a sample of 30, we're using the sample standard deviation and not the population. All right, so I'm going to take my data again. And then hit enter. All right, so this is my standard deviation, and this is my x bar. So I'm going to just round the standard deviation to about 4.6, okay? Actually, let's be, yeah, so 4.6 sounds fine. And then we'll round this x bar to about 165.9, just so that we have a little bit easier numbers to deal with. Okay, so that's about my average. That's about my standard deviation. So now we're going to actually draw this out because now we know it's approximately a normal distribution. So I'm going to assume that it's a perfectly normal distribution. Okay, so if we assume it's a nice normal distribution, then the value in the middle is 165.9. And remember that the standard deviation, it's going by one standard deviation on each side. So if I add we know my standard deviation is 4.6, right? So I'm going to go ahead and add 4.6 to that, and then another 4.6, and then another 4.6, and then I'm going to take away 4.6, okay? So I'm going to do that real quick, but I'm going to do that on Excel because it's going to save me some time. So I'm going to do 165.9 plus 1 standard deviation. I'm going to do 1 times, yeah, I'm just going to do this, 4.6, and then the same number plus 2 times 4.6, and then the same thing plus 3 times 4.6. All right, and this gives me those numbers, so I can just use those automatically. And then I'm going to do the minus version. So minus 4.6 minus 2 times 4.6, and then lastly minus 3 times 4.6. That way I have all the numbers on the x-axis. All right, so we're going to label those numbers here. I have to erase all of this. Here, let me just select all of these real quick. All right. Okay, so we have our 165 point. It was 165.9. We have 170.5, 175.1, and 179.7. All right, so we have a nice normal distribution, and it's labeled with our numbers, okay? So now that we got the numbers, remember the empirical rule states that 68% of your observations is going to be between one standard deviation above and below, so about 68%. And then remember that the empirical rule states that 95% is going to be between 2 above and below the mean, and then and so on, and 99.7 for 3 above and below. So we're going to see if this rings true here for our distribution. So for us, we should have 68% of the data between 161.3 and 170.5. Okay, so those are the numbers that we want to look at. Now, is this true? We want to see if this is true. 161.3 to 171.5. I'm just going to type that in so that we have it. So now what we're going to do is we're going to just look at the numbers. We're going to count the numbers between those and see if that represents about 68% of our data. Okay, so we're going to tally the numbers between those two. I'm going to bring this up so that I can look at my data. Okay, so 161.3, that would be here, 1, 2, 3, all the way to 171.5. All right, so that's about there. So that's 21 numbers. Okay, so we got 21 numbers that fit that criteria. So it's 21 out of 30, right? So we got equals 21 out of 30. All right, so which is about 70%. So 21 out of 30 is about 70%. So this is actually pretty close to the 68%. So this is actually really good. All right, so this will be some exercises that you'll have in your lab where you have to determine this. So if it's following the empirical rule and we have the test for normality, this means that we're doing really well as far as collecting our data and following the normal distribution. All right, guys, that's it for the lab. I hope you took a few things from this, learned a few tests, and I'll see you in the next one.